Hi guys, it's Michelle, and this is my chapter 456 summary of Extending Children's Mathematics. So I found chapter 4 interesting. It's talking about connecting fractions to algebra and how learning fractions and teaching fractions to the students will lay the foundation for them to learn and understand the concepts of algebra. Once again, it's revisiting what we've been talking about all semester, talked about in the last video, that our text supports it. This book supports it, our readings have supported it, that we are, as teachers, um, encouraging students to use their own strategies to problem solve. Here, they'd be doing it for solving fraction problems, and therefore, this will lead them to the foundational skills of algebra. Children need to understand fractional quantities, and students who can express a number in terms of other numbers and operations hold the relational understanding of that number. It is the beginning of algebra, the foundation of algebra, because um, when you have the fractions, and you see them written out, you're solving for an unknown amount, an unknown number, and that is part of algebra. So once they can understand the whole numbers, go to the fractions will lead you to the unknowns, to the algebra. It's a progression. It talks about, once again, doing fractions through equal share problems, where, you have one amount, we have to share it equally among this many people. It talks about then the grouping, multiple groups problems with fractions and relational thinking, shows students that relational thinking, as they use the grouping strategies, they use it to simplify their calculations, and over time they develop more sophisticated strategies. Chapter 4 shows us the necessity of these foundational skills and how important it is that students draw upon previously learned knowledge and skills to solve these new problems. Doing this, taking what they've already learned and using it to solve the fraction problems, and with their relational thinking, it shows focus, it shows mastery of the skill, it shows their strategy, it shows their progression from the earlier chapters on for the things that they've learned. We need to support students' use of relational thinking in math because it's necessary for them to understand the fractions and operations. Relational thinking is used to make sense of numbers, operations, and equations. And I can only say it as like all the layers add up. They have to understand that it's not just this problem or this chapter, that what they learned before about the numbers goes into their problem solving, their group problem solving, their equal share problem solving. Now we're solving for fractions and how it's pieces of the whole numbers. And then we're solving to try to find some unknowns, and that goes onto their algebra. And once students understand and master whole number expressions, then they can transfer to working to their fraction expressions. And the teacher commentary talked about, very important, the children must understand fractions as more than just pictures, but as the numbers. They have to learn it in elementary and middle school to be able to move on to the high school algebra. They must understand that fractions are related to division and work from there when learning the algebra. When students can understand the fractions, they can make the connections necessary and can reason out strategies to solve problems that they haven't had yet. And they're stress showing the numbers, not pictures, where they teach fractions, which I thought that was interesting because in the earlier chapters and other things that we've done this semester, we're always telling the kids, or learning to tell the kids, when in doubt, draw it out. Draw a picture. I see it in my school all the time. Make the dots. Use these counters. Use these charts. But here the teacher commented that it is important to really get into the kid's head the fractions are the numbers. It's not the picture. I know we do pizzas and breaking up the candy bar into pieces on the rectangle, but here she's really saying we have to teach the numbers. They have to understand the numbers because once they go from the fractions and then into the algebra, they can't be drawing everything. They have to have some of these foundational skills about the numbers. The teachers must be the ones to facilitate the students in making connections in the foundational skills before for the fractions, and they have to know these foundational skills. We have to ask them the important questions as they're learning. because the fractions lead to algebra. Each piece, it's a progression. And a key element I found in Chapter 5 was that the teachers have a new role that they're teaching. The teachers are encouraging student strategies created, student created strategies, student solving the problems. As teachers, we must carefully plan the problems. We must definitely facilitate communication among the students to share their ideas and continually assess the students' thinking so that we can help guide them. We have to be walking around, listening to what they're thinking about the math, seeing what they're writing down about the math. That way we know where to go next and to guide them. There was an example of the teacher, Ms. Perez, and the students needed to solve the problem their own way, whatever way it made them comfortable. She started fractions, with the whole numbers. She moved down to fractional with equal share problems, then multiple group problems. She continually checked in to assess their strategies and thinking, and that's a key element. I think that's important in math especially, but in most of our classes, but definitely math. You have to be walking around, you have to be listening and seeing what they're doing. That way you can kind of focus them and guide them if they're off task. We're encouraging students to share their strategies to help them make connections with each other. This has been discussed all semester. These are the same concepts. They're really, being drilled home that students need to explore their own strategies, share with others, build upon previous knowledge that they've learned for the math skills as foundations. They're encouraging math to talk and discuss, trial and error. And once again, we're letting them explore before we're just telling them, when you add fractions, this is what you do. When you subtract fractions, this is what you do. They're trying to let them figure out what you're solving for, how is the fractional number in relation to the whole number. It's important to let them explore. Also important in Chapter 5 that children must understand the difference between an equation and an expression. An expression is a representation of one amount, where an equation represents an equivalence relationship between two or more amounts. And then Chapter 6 is understanding the fraction, equivalence, and order. And once again, the children are using what they already know, building upon their existing knowledge, and growing their understanding of fraction, equivalency, and order. It was very interesting that the book did not advocate using any manipulatives for teaching the fraction, equivalency, and order here, because we're always talking about manipulatives. I love them, the counters and the little pieces and all this stuff, but the book is saying that using certain manipulatives for fractions, the students don't always understand that the fraction should be related to a number and not the actual physical manipulative. It can actually be unhelpful here. And that's a sharp contrast to what we've read and discussed, but it doesn't always apply to fractions. They do recommend tools for fractions, plain old paper and pencil, cut out paper that you can fold and cut to make fractions you need, pencils or markers to differentiate the shares, and certain linking cubes. That those are the best tools for fractions. And once again, a very important thing that I got from this was listening to hear the students and their emerging strategies. The teachers must question the students, prompting them to reflect on their thinking, use students' equations to compare solutions, and once again, we're strategizing, they're formulating, they're computing, they're sharing, they're discussing, they're reflecting, and the teacher has to facilitate this. They have to facilitate the share, the discussion, and elicit students' mathematical thinking about the math relationships that they already know are true. And students have to, still create their own strategies. The teacher has to get them talking, get them sharing, get them discussing. They have to share, they have to reflect, and they have to build upon the previous knowledge as they work from the whole numbers to the fractions, the understanding of the fractions in regards to relational thinking, and then going forward to the algebra. It was a little long, guys. I'm sorry, but I had to get it all in there. And that's my summary. See ya last two chapters.